So here we are on our day 3 of Leetcode 75 Strong Challenge. I'm here on my um, third question here, kids with the greatest number of candies. So let's begin. In this question, they're asking kids with the greatest number of candies. There are n kids with candies. You are given an integer array candies where each candies element I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. Return a boolean array, that means an array of true or false, result of length n, where result I is true if after giving ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. Note that multiple kids can have the greatest number of candies. So we have this question here and we have these examples as well. You can see in this, we have this input here. I know it's a lot of jargon here, a lot of description, a lot of text. But long story short, what they're looking for here is we have this array here, right? Where where each element of this array represents the candies that a kid has. So for example, this kid here has 2 candies, this kid here has 3 candies, and so on, right? And then we have an extra variable called extra candies that tells us like how many extra candies do we have so that we can give it to the kids. Okay, so that's it. That's the gist of this question. And then in the question, they're asking to find the maximum. So for example, if you give all of your candies to this kid right here, this will become 2 plus 3 5, right? So then now this first kid has 5 candies. Is it greater than the max amount of candies that we had before we did this? So for example, the max candies we had earlier in this list was 5, right? So when we add our extra candies to each kid, is that higher or equal? That means it's a good thing. That means then we will return true, right? And but if that, even after adding that, like for example, if we add the 3 extra candies to this kid here, which had 1 candy, 3 plus 1 is 4, which is less than the max we had, which was 5, right? So in this case, this will be false. That's why this guy is false. But if I add 3 plus 3 to the last kid, that means this kid now has 6 candies, which actually exceeds the max that we had, which was 5. That's why it's true. So hopefully you get the idea. It's a bit of a confusing text in the question, but you know what? It's actually not that hard when you come down to solving this question. So how I'm going to solve this question is very simple. I'm going to define a couple things here. The first thing first, we need to find the max amount of candies a kid had in this list. Okay, so let's just call that max candies, and I'm gonna find the max from this list here, which is candies list. So this will give us the max. Okay. um, the second thing I'm going to do here is I'm actually going to define my return list, because in the end, they're actually asking us, give us a Boolean array, return a Boolean array, right? So I'm going to have my list here, return list, which will be an empty list right now. But as I do my calculations and things like that, we will start appending to this, right? Third step, obviously, we have to iterate over this list. Now we have the max, and we can iterate over the list, and then we can compare each element with our max candies. Okay, so let's write a loop here. I'm going to do for candy, because individual element of this candies list is candy. So that's why I'm calling it candy. For candy in candies list, if candy, whatever number we had initially, plus extra candies. So if candy plus extra candies is greater than equal to our max candies, in that case, we're gonna append a true to our list. Dot append, and it's gonna be true. Else, that is, if the even after addition of extra candy, if this is still smaller than the max candies, then we just gonna append false to our list. Okay, hopefully you get the idea. It's a very simple question, actually. In the end, we're just gonna return our list since everything is iterated over now. So we're gonna return our list. Okay, and let's run this and let's see if this passed the test results here. Okay, accepted, looks good. Submit. And there you have it. Pretty good runtime here, 100%. Beats 100% of the people, I guess, and it's pretty good. Looks pretty good. And now for the complexity analysis part of this question. Uh, Obviously, we're looking for time complexity and the space complexity, right? So what is the time complexity of this specific solution? In our case, the time complexity of the solution is ON. And the reason for that is we are iterating over when to find the max here on line 4. We have to iterate over this entire list. So this will have a time complexity of ON. And then again, when we are doing this iteration here on the candies for our calculation, we still have to iterate over the entire list. So this is again ON. So right, so we have ON, but as you know, in complexity analysis in Big O, we actually only care about, we don't care about two ON, we actually just care about the singular ON. So that's why we're going to represent that by this. And the space complexity in this is going to be O of 1, which is constant. The reason for that is without obviously counting the space of input and output. So we don't really care about how much space was taken by the input here and how much space was taken by this output here. So we usually ignore that. So that's why if we look inside now of that input and output, we don't really have anything that actually is using a significant amount of space here. We have these variables and things like that. We are using this max candies variable, for example, but it's not really that significant. Okay, so without counting the space of input and output, we are not using any space except for some integers like max candies and candy, right?